And I want to give you time in class to do the test review, so let's quickly get going here. So number one, it says graph the function. What you're going to do with these guys, and you need to know how to do this because we're going to give you one that you aren't going to just be able to use your graphing calculator because it's not a known function, and we'll talk about that. But looking at this one, the first thing I would do is write out what is the parent function. Remember, parent function is the function that of this type that's non-shifted. So wouldn't the parent function be f of x is equal to the cube root of x? That would be the non-shifted of this function, correct? Yeah. So that's what you're going to do first is identify the parent function, and then you're going to write out some x, y points from the parent function. X, f of x. That's what we know y is f of x. So just plug in some points. What's the cube root of -1? The cube root of -1. -1, right? So I'm going to plug in -1 and I get out -1. Do you see what I'm doing here? Plug in 0, I get 0. Plug in 1, I get 1. I'm going to use like 3 or 4 points, maybe 5 points. I'm just going to go with 3 for this first example so that we can stay basic. Okay, now we are taking these values, and the first thing you're going to do, so these are the steps you're going to take. First, find the parent function and list out some x, y points. Second, you need to perform any reflection, stretch, or compression to the appropriate x or y values. That's what you've got to do first. If there's a stretch or compression, you're going to multiply it to your y values. If there's a reflection, it depends what reflection we're doing. And then you'll translate it third. So here we go. Is there a reflection? Yes. So if we have an XY chart, guys, that is a reflection over the x-axis, correct, everybody? So that would be taking and reflecting it over the x. Wouldn't that be just changing our y's to the opposite, like -1 times y? Yep, so we're going to change all these, multiply all these by -1. So our new y's are going to be +1, 0, and -1. So I've done this translation. So now we're going to go and we're going to take all of these x, y points, which is the graph, right? Graphs are just x, y points. So you get why I'm using the points? And I can just plot the points and draw the new graph. So now we're taking all of these points and we're shifting them right to. Isn't that a shift on x? We're going right to, correct? So we're going to add 2 to all our x values. And then we're going up 3. That's shifting the function up 3. So we're going to go up 3. That would be y values because that's a shift up and down. So we're going to add 3 to our y values. So what are our new x, y points? Let's write them out. So we add 2. So 1, 2, 3. And then we add 3. So that'll be 4, 3, and 2. So now we can plot those points on an XY chart. So go to your XY chart. You're going, I'm going to get this color. Over 1, up 4. You're going over 2, up 3. And you're going over 3, up 2. And now that's not really enough points to draw the perfect graph. But at this point, it would be absolutely okay to go ahead and graph it in your graphing calculator and just plot a couple more whole number points. Does everybody see what I'm saying? So go to y equals in your graphing calculator, type this in exactly as you see it. Since you've shown your work, I understand that you now know how the shifting works. It would be fine at this point. So now get some other points by just plugging it into your calculator and going to the table of values. So then you can check your answers because those points better match up. Do you all understand what I'm doing? If not, tell me because I can help you. So let's all type it in. Negative. Do you know how to type in the cube root? You go to math and then down to cube root. And then you type in x minus 2. Do I need to pull it up on my big calculator or are we okay? Because I can. Okay, so you can see
y equals
So some values. Let's go whole numbers. Did we get 1, 4? Yep. 2, 3. Yep. 3, 2. Yep. Another whole number point. I'm just scrolling down. Is 10, 1. So over 10 up 1. And then another whole number point. I'm going to go in the negative direction. No, I'm just using my table of values. You know, like these. I'm just going to use the table of values we already have. Then I can check my x, y points. And then another whole number point, I'm scrolling up. I have another whole number point is -6 up 5. So now I have enough points to draw a -6 up 5 in a graph, and it looks like this. Does everybody feel a little bit better about that one now? Okay, awesome. Maybe let's do number 3 real quick, or just talk about it. So this is an x to the 4th. So my parent function would be x to the 4th, correct? So we would do the same thing here, x, y. Let's plot out some points. So I'm going to do, let's do a couple on this one. -2 to the 4th, right? -2 raised to the 4th is 16. I'm plotting out some points from the parent function. If I plug in -1, I get 1. If I plug in 0, I get 0. If I plug in 1, I get 1. And if I plug in 2, I get +16. Now careful here, because see how this 1/2 is also in the parentheses? So that's 1/2 to the 4th power. 1/2 raised to the 4th power. So our factor is actually 1/16. 1 to the 4th is 1, 2 to the 4th is 16. So now we're taking and we're compressing it by a 4th. Anytime you stretch or compress, the only thing you multiply is your y values. Did you all hear that?
Wait, no. Oh, yeah.
So anytime you stretch or compress, it's a vertical stretch or compression, so we only multiply our y values. So let's multiply all of our y values. That's what we always do first, is do a reflection or stretch or compression. We're going to multiply all these y values by 1/16. Yes, because we took 1/2 because it was in parentheses raised to the 4th. If it was just 1/2 out here, we wouldn't raise it to the 4th. We'd multiply by 1/2. But just because it's in parentheses, that's also raised to the 1. Raised to the 4th. So we're timesing by 1/16 to all of these. So let's write out our new xy points here. So we're still going to have -2, -1, 0, 1, 2. Here we go. 16 times 1/16 is 1. You should see that right off the bat. And we have +1/16 and 0, 0, and 1/16, and then 1. Sweet. Now we're going to do a downshift of 2. So we're going down 2. That's a shift on the y, correct? So now we're going to take our y values, subtract 2, subtract 2, subtract 2. And now we have new xy points we can plot. And then after you've shown me that you understand that, I'm okay with you just plotting, using your graphing calculator to get some more points if you need. That's plenty of points. Does that make sense, everybody? Okay, awesome. So what I want you to do is you're going to see ones like number 5, most likely on the test too. So make sure you can do this. So we have this picture on number 5. We're going to take our function. Now this isn't any function we know. It's not a cubic. It's not a whatever. Anyways, I don't know if I didn't draw it perfectly. So look at your paper here. These are some points. Yeah, I didn't draw this very good, but it's okay. These are I just am going to choose to use these points because do you see how those are like significant points? They land right on whole numbers. Does everybody see what I'm doing? Okay, so we're going to take 2 times the function. So this is a stretch of 2. So you're going to take and figure out your new xy points. Stretch and compressions only affect your y values. So take these and multiply by 2. So won't that be, we're going to times by 2 to our y values. So my new xy point so far is 4, 4, 3, 6, 3, -8, and 6, -8. Oh, perfect. -4, 4. Good fit. And now we're going a shift of right 1, and we're going up 3. So remember, right 1 is a shift on x. So we're going to go to our x's and we're going to add 1 to all of those. And then we're going to shift up 3. So we're going to add 3 to our y's. Now you have new XY points. We could write them out, plot them, draw it, you're done. So hopefully after that, you're feeling a little bit better about those. So they're really not too bad as long as you know what you're doing. That's a 1. So we have -3, 7. We have 4, 9. We have 4, -5. And we have 7, -5. Those are your new points, and then you can connect it because it's still the same function, it's just been stretched and shifted. Sweet. Okay, so the rest of the time is yours to do the test review and get help in class, check your answers. The key will be uploaded online.